we were interested in looking at the human fossil record from which before about 2 million years ago is all in the continent of Africa. And it's what a lot of people know and have pointed out is that the fossil record isn't from all over the continent of Africa. There are a few hotspots where fossils get preserved. And one of the most important hotspots is in East Africa, Eastern Africa. It's called the East African Rift Valley, and there's a bunch of depositional systems there, basically where sediments accumulate in these valleys and preserve fossils. But the issue is that it's a very narrow strip of the continent of Africa, right? It doesn't sample the whole continent. So we want to know what's the impact of the fact that most of the fossil record from the earliest parts of human evolution comes from this really narrow sliver. What might we be missing about the environments that early humans lived in, about their anatomy, because we only have this relatively narrow sliver, this snapshot from this restricted area. So we looked at sort of two aspects of the question. First, we looked at the environments that might be preserved in these sediments. And we looked at how do the environments within the rift system differ from the environments outside of the rift system. And we found that, perhaps unsurprisingly, if you've ever been to the rift, it's much drier, there are fewer trees, it's much grassier than the areas that surround the rift. And this is driven by differences in precipitation, differences in climate regime that are actually caused by the rift itself and the differences in elevation surrounding the rift. And so basically what that means is that to the extent that this situation was true in the past, that the fossil record that we have is only capturing part of the picture when it comes to the environments that human ancestors would have lived in. And then we also looked at widely distributed primate species, different monkey species that live today for part of their time in the rift, part of their range in the rift, and then also live outside the rift. And we said, what would we be missing about their anatomy, about their skull shape, because we often have skulls preserved in the fossil record? What would we be missing if all we knew about was their occurrence within the rift? And not surprisingly, we miss out on key aspects of their variation if all we can sample is what's in the rift. And what's interesting is that, and again, this is pretty intuitive finding, is that if there's gradients of variation that go north-south, they're easier to capture in the rift because the rift is oriented north-south. If the gradients of variation are east-west, then you miss out on a lot of them because the rift is oriented north-south. And so this is, again, a pretty intuitive finding, but we were able to show and quantify the magnitude of that in our paper. I think it's important because our picture of what human ancestors where human ancestors were living and what kind of environmental pressures they were facing is a really key aspect of how we answer why questions in human evolution. Like, why did humans get big brains? Why did they start walking on two legs? And those questions are often based on our interpretations of the environments that these species lived in. And so if our picture of what environments they lived in is only part of the true picture, then we need to understand that, and we need to try to come up with ways to figure out how to correct for that, for the fact that our sample, it doesn't have all of the range of variation that our ancestors might have been living in. And so I think capturing that, and I think quantifying the disconnect between what we can see from within the rift versus what might have been more widespread is really the key takeaway of the paper. And it's really why I think these findings are really important for people when we're trying to understand what drove human evolution, what drove major transitions in human evolution.